Hello everyone, welcome to Drishti CUET and welcome to your very important chemistry class. Here we are going to discuss with chemical kinetics, which is one of the important topic for your CUET exam as well as for your CBSE board exam. Now under this topic chemical kinetics, basically we are going to cover few sections, that is introduction to chemical kinetics. That means first of all we'll understand like what do you mean by chemical kinetics, right? And then we'll talk about the various types of chemical reaction. Now we are not going to discuss the types of chemical reaction like endothermic, exothermic or displacement reaction, double displacement reaction. We are not going to talk the chemical reaction depending upon their type, what are the product they form. We are going to discuss the type of chemical reaction based on their rate, right? Like how fast any reaction takes place, how slow any reaction takes place. So based on that we are going to discuss the different types of chemical reaction, right? Then we'll discuss about the rate of chemical reaction, how you are going to define the rate of any particular chemical reaction. After that we'll discuss about the average and the instantaneous rate of reaction, which is again an important type, right? So here we will discuss, also we will discuss like how you are going to write this average and the instantaneous rate. Then the factors affecting rate of chemical reaction. So basically what are the factors which affect the rate of any chemical reaction, like due to that factor the rate maybe increases, the rate of reaction maybe decreases. So those factors also we are going to discuss in this particular session, right? After that the rate constant and the rate law, right? What are rate law, how you are going to define the rate constant, these are the things we will discuss. Order and molecularity of a reaction, we'll also discuss about the pseudo molecular reaction. So these are the few important terms in your syllabus, so we'll discuss these in this particular session. All right, so here let's begin with the introduction part. So guys, first of all, this chemical kinetics is the branch of chemistry, or you can say it is that branch of chemistry which deals with the rate of reaction, or you can say with which we are going to understand the speed of any reaction, right? So it is a branch of chemistry which deals with the study of reaction rate and their mechanism, like how fast any reaction takes place. So when we will study all those parameters now, so those parameters will understand or will study under the branch of chemistry known as chemical kinetics, right? See, in thermodynamics also we will discuss about the rate of reaction only, right? In thermodynamics we will also discuss basically that whether the reaction takes place or not, right? We will talk about the feasibility of a reaction, okay? That means like suppose we have any particular reaction, just take an example, we have iron mixed in a copper sulfate. So in thermodynamics basically we get to know about the feasibility of a chemical reaction, that whether any reaction takes place or not, right? Like when we mix iron in a copper sulfate, okay, we'll get ferrous sulfate and the copper remain isolated. So this reaction is feasible, you will get a product, okay? But suppose if you mixed copper in a ferrous sulfate, the reaction will not takes place. Okay, so that feasibility, whether the reaction takes place or not takes place, that we will understand or that we will study in thermodynamics, right? But in chemical kinetics, we'll talk about the speed of chemical reaction, the rate of a chemical reaction, like how fast any reaction takes place. So the kinetics, under the kinetics we'll discuss these only now. For an example, like suppose diamond, okay, diamond converted into a graphite, that means this reaction is feasible. So thermodynamics tells you that okay, after some time diamond converted into a graphite, but chemical kinetics tells you that how much time it will take to convert, right? So the time, that speed, or the how fast, right, how much year it will take to convert, that is the kinetics only, that we will understand in the kinetics. Okay, so basically kinetics, the study of chemical kinetics, not only help us to determine the speed of any chemical reaction or the rate of reaction, but also it describe the factor, or also it describe the condition, right? It describe the condition by which the rate of reaction can be altered. So in the chemical kinetics, you are not going to only discuss about the speed of a reaction, but also the factors, right, which is responsible to affect the rate of reaction. Just take an example. Suppose you have to reach your school or college, right, and the distance is suppose 5 kilometers from your house. You will take hardly 10 minutes to reach to your school or your college. Okay, so the distance upon time only, that is the speed only, na. So that defines that how much time you will take. 10 minutes only to cover 5 kilometers, for an example. So that is the speed, like what you take by like to reach your school. But now suppose someday you meet with traffic, right? You have a lot huge traffic jam on your way. Then the 5 kilometer distance, the same 5 kilometer distance you will take to cover within 1 hour. So now what happens? 60 minutes required to cover 5 kilometer. So now the speed changes, na? The rate of reaction, like you will go late to your school, you will reach late, right? So similarly, in the chemical kinetics, we are not going to understand only the chemical reactions speed, but also few factors which alter the rate of reaction, why some reaction takes faster, why some reaction occurs slower. So we are going to discuss all those factors also in the kinetics. Okay, so based on their speed, based on their rate of a reaction, chemical kinetics divided into, or you can say that chemical reaction divided into 3 types. What are the 3 types? Very fast reaction, moderate reaction, and very slow reaction. So basically we have 3 types of reaction: very fast, moderate, and very slow reaction. Very fast reaction means like magnesium. Take an example, magnesium and hydrochloric acid. So whenever you mix metal with a acid, so what happens when a metal mixed with a acid? You will get a salt as well as hydrogen gas releases. So as soon as you mixed metal with acid, you will get salt and the hydrogen gas releases. So this reaction takes place very fast, within a second the product formed, right? Like when you dissolve sodium, like you have a sodium pellet, and when you add water droplet within the sodium, very fast the test tube become hot, the exothermic reaction takes place, right? So here what you can say, that the reaction which will takes place within a second or within 1 or 2 minutes, right, that reaction considered as a very fast reaction. Moderate reaction, like the reaction or the speed, like which the reaction which takes place few minutes or few hours, that you can consider as a moderate. Like spoiling of food, like once you prepare the food and you kept it for some time, like the next day, like in winters it will take 1 or 2 days, but in summer, like next day only your food become spoiled, right? So that means now the oxidation reaction takes place, your food get oxidized and spoiled, right, become rancid. So this reaction takes few hours to few days, that is called moderate reaction. Rusting of iron also sometimes takes so many days, right? It will take 6 days, or within a week, or 10 to 15 days you may got a rust in your iron. Baking a cake, so when you bake a cake, it will again take 1 to 2 hours or 3 hours sometimes. Digestion of food, cooking, so these are some of the reaction which considered under a moderate rate of reaction or moderate type of reaction. Then we have very slow reaction which will take years to complete, right? So here, like the formation of diamond, weathering of rocks, setting concrete, silver tarnishing, these are some of the reaction which will take longer duration to complete. So बेस्ड ऑन देयर टाइम, सी हम रेट कैसे बताते हैं, किसी चीज के भी रेट अगर हमें बताना हो, दैट रेट वी विल डिस्क्राइब विद रिस्पेक्ट टू टाइम ओनली, राइट? लाइक इतना डिस्टेंस कवर किया, लाइक सपोज इफ एनी व्हीकल इज मूविंग, राइट, 5 किलोमीटर पर आवर, सो दिस इज व्हाट, दिस इज द रेट. व्हाई? बिकॉज वी आर डिस्क्राइबिंग द डिस्टेंस विथ रिस्पेक्ट टू टाइम. तो जब भी टाइम के रिस्पेक्ट में हम बात करते हैं, वी आर डिफाइनिंग द रेट, राइट? लाइक सपोज आई हैव स्टडीड 3 hours इन अ डे, तो 3 hours इज द टाइम ना. So with respect to time, my study calculated, that is called the rate. Clear everyone? The types of reaction based on the rate of reaction, right? Now let us understand the rate of chemical reaction. How you are going to define the rate of any particular chemical reaction. So basically the speed of reaction or the rate of reaction defined as change in the concentration of reactant or product in unit time. Now what is reactant and product, guys? Reactant, something which is present in the left hand side, product, something which is present in the right hand side. Okay, now concentration always represented with the square bracket. So whenever we just put the square bracket now, it tells you the concentration. Okay, so here what we can say, that the rate of chemical reaction defined as change in concentration of a reactant or a product in unit time. It can be expressed in the term rate of decrease in concentration, increase in concentration of product. So just understand like that, whenever any reaction takes place, okay, there is a change in concentration at the reactant. For an example, okay, let us take an example. Suppose cooking of food. Okay, so what happened, whenever you cook the food, initially all the vegetables are raw and they are in a large quantity. Okay, now once you add everything, okay, in a pressure cooker or somewhere, add all the masalas, salt and everything, once the vegetable prepared, right, what you will get the lesser amount of the product. Like जितना आपने quantity पहले ली थी, उसका थोड़ा सा amount का सब्जी बन के आता है, right? So what you can say, there is a change in concentration na of product and the reactant. Take another example, like suppose if you add any chemical, like suppose you add any chemical compound, suppose water and take hydrogen and oxygen. So they are what? They are again the gases, hydrogen and water, oxygen. When you mix them, you will get a water. So obviously at some stage, the hydrogen gas molecule and the oxygen gas molecule reduces, they combine together. Initially they are free, but when they mix together, they started combining together, right? And ultimately you will get H2O liquid molecule. So at one side the reactant decreases, at other side the product increases. So both the side there is a change in the concentration na. So this is how you are going to define the rate of any chemical reaction. That rate of chemical reaction, change in the reactant and product. And this can also be described as always there is a decrease in concentration of reactant and increase in concentration of product. Obviously, जब reactant utilize होगा, when the reactant utilizes, then only the product form na, right? When A and B utilizes combined together, then only the product AB form. Okay, so always there is a decrease in concentration of reactant and increase in concentration of product. Okay, so you can also define the rate of reaction as the decrease in concentration of any one of the reactant or the increase in concentration of the product. Okay, this you may also understand with this graph. Okay, see, initially what happened, this vertical line tells you about the concentration and this horizontal line gives you the time in minute, right? So what you have seen here, see, this is the flask having pink color molecule. Okay, so now all the pink color molecule is in very higher quantity, like the concentration of pink color molecule is higher. Okay, when at time 0, so at 0 minute you have 1 molar concentration of this pink molecule. Okay, as the time passes and the reaction started, okay, as the time passes, the pink color molecule started converting into a green color molecule. Okay, so pink is the reactant, green is the product. So as the time proceed, like see, after 20 minutes, what you have seen, now here you have some green color balls, some green color molecule also. Okay, but the concentration decreases, right? Initially it is 1 mole, but now it is 0.5 approx some mole. Okay, now after 40 minutes, what you have seen, that concentration of pink color molecule again decreases and the concentration of, you see, this green color molecule increases. Now the reactant remains 0.3 or 0.2 molar, whereas the product is 0.7 molar approximately. Okay, so now what you have seen, like slowly as the time passes, the reactant molecule decreases and the product molecule increases, and ultimately no reactant molecule left, only the product molecule will be left over. Okay, so that means what happened? The concentration changes, na, product and the reactant concentration changes. This is what we can say that rate of chemical reaction. This is how you can define the rate of chemical reaction. So now consider a hypothetical reaction. R is the reactant, P is the product. Okay, so consider a hypothetical reaction assuming that the volume of the system remain constant. Okay, now here the volume is constant, you have a same size of a beaker, the volume is constant, reactant converted into a product. 1 mole of the reactant R produces 1 mole of the product. So 1 mole reactant produces 1 mole product. We also know that the conservation of law we have learned, right? So conservation of chemical reaction, what does it say? That whatever the amount of mass you have added or you used in the reactant, same amount of mass you will get in the product form. So 1 molar reactant produces 1 molar product. If R1 and P1 are the concentration of R and P, okay, R1 and P1. What is R1? The reactant concentration at time T1. So when at time T1, reactant is R1 and product is P1. As the time passes, at time T2, now the reactant becomes R2 and the product becomes P2. Okay, so different time, the concentration of reactant and the product changes. So what is delta T? Change in time. Delta T is what, guys? Change in time. Okay, delta T is the change in time, like T2 minus T1. T2 is the final time, T1 is the initial time. That will tells you the delta T. Delta R is what? The change in the reactant. Okay. Delta T is change in time. Delta R is what? The change in concentration of reactant. Similarly, delta P is what? The change in concentration of product. Okay, the change in concentration of product. Now the square bracket, always I told you, the square bracket always tells you the concentration. Okay, जहां पे भी अगर square bracket रखा हुआ है, that means we are talking about in terms of concentration. Okay, so now how you are going to write down the rate of chemical reaction? Rate of reactant decreases. That means once the reactant disappear, then only the product appear, na? Once the pink ball started disappearing, then only the green molecule started appearing. So here the reactant always disappear. Okay, so the rate of disappearance of R is equal to decrease in concentration of R by time taken. Okay, decrease in concentration of R by time taken. So here minus delta R by delta T. Okay, delta R by T. See, what is decrease in concentration of R? We are adding minus sign. Why? Because the reactant concentration decreases. That's why we are added minus sign. Time taken. Since we are calculating the rate always calculated with respect to time. Clear? So, rate of disappearance of R is decrease in the concentration of reactant upon time taken. Similarly, as the reactant decreases, the product formed, the product increases. So the rate of appearance of P is equal to increase in concentration of P. For increase, we have added positive sign and divided by time taken. So negative and positive sign, please remember, because this is the only crunch you have to remember in this particular topic, right? Most of the time you guys forgot adding minus and plus sign. Minus sign indicates decrease in the reactant concentration, plus sign indicate increase in the product concentration. Okay. Now, how you are going to write down the rate of reaction? Suppose this is the general reaction AA, BB, CC, D. Right? Initially, just take a reaction A plus B gives C plus D. Okay. So now, if you have to write down the rate of chemical reaction, A and B is what? They are reactant. C and D is what? They are product. Okay, so now this is one reactant, this is another reactant. So concentration, what is the rate law equation? Concentration of reactant A decreases at time t minus equals to, now the rate of decrease of concentration of A always equal to the rate of decrease of concentration of B. Okay, so here what you can write equals to B by delta T, which is also equals to rate of increase of concentration of product C, which is equal to rate of increase of concentration of D with respect to delta T. So this is the general form of reaction. Okay, how you are going to write. Now if the equation has a small a, b, c, d, these are the stoichiometric coefficient. Right? It's not like always you are using a reaction like this only. Okay, sometimes you have added 2A of A. Suppose now you are taking 2 molecule of A, 1 molecule of B, and what you will get 2 molecule of C, 1 molecule of D. So if the reaction is this, how you are going to write down? 1 by 2 A divided by delta T. So minus. So this is how you can write down the reaction. So A, B, C, D is what? They are the stoichiometric coefficient. And if they are given, how you are going to write down? The rate of reaction is rate of disappearance of reactant. See, 1 by A by delta T equals to minus 1 by B del B by delta T. Similarly, rate of appearance of product 1 by small c del C by del T equals to 1 by D del D by del T. So, this is how the complete rate of reaction you will write down for this particular reaction. So, first of all, though, you have to practice the rate of reaction. Okay. How you are going to write down the rate of reaction? Once you understand writing rate of reaction, then only you are able to solve other questions related to the chemical kinetics. Okay. So now this is what I have already discussed. Here we have few questions, like till now whatever you have understand, just try to solve. What is the rate of a chemical reaction? Just try to solve everyone. Give a pause and try to answer. See, the rate of a chemical reaction is time taken for a reaction to complete, the change in concentration of reactant or product per unit time, total energy released during the reaction, the amount of catalyst used in the reaction. So see, always I told you, the rate of reaction is what? The change in concentration of reactant and product. Okay, so here option B will be the correct one, change in concentration of reactant and product. Then next question, for the reaction AABBCCDD, the rate of disappearance of A is related to the appearance of C. So now how you are going to write down the rate of chemical reaction? A for A and C. So what is the reaction here? Small a, capital A, small b, capital B gives you small c, capital C, small d, capital D. So what you have to write down? The disappearance of A. How you are going to write down the disappearance of A? 1 by A minus disappearance, so minus delta A by delta T, right? And the disappearance of C, 1 by C delta C by delta T. So this is how you are going to write down the reaction. So here the correct option is what? See here, 1 by A minus 1 by C. So this is your correct option. Okay, so like this you have to practice few questions. Once you practice all those questions, you are able to solve the answers. Okay. Next, in the reaction H2 plus I2, okay, gives 2HI. What is the reaction? H2 I2 gives you 2HI. Okay, if the rate of appearance of HI is 2 into 10 to the power minus 3, see, rate of appearance of HI is 2 into 10 to the power minus 3. Okay, what you have to find out? The rate of disappearance of H2. You have to find out the rate of disappearance of H2. Alright. So now, first of all, try to write down the rate of reaction. Okay. So for H2, how you are going to write down rate of disappearance? No stoichiometric coefficient is here. So simply delta T equals to 1 by 2 delta HI by delta T. This is you are going to write down. You have to find the rate of disappearance and the rate of appearance. So this value is given 2 into 10 to the power minus 3. So this cut, what you will get, 1 into 10 to the power minus 3. So the correct answer is your A, 1 into 10 to the power minus 3. Alright. So this is how you have to solve the questions. I hope till now thing is clear to everyone. Okay. See, try to understand the concept, basic concept. Once you understand the basic concept, then further the topic becomes easier and easier. Okay. So till now what you have understood, the chemical, what is rate of reaction, okay, how you have to write down the rate of chemical reactions, right, what are the types of chemical reaction based on the rate. So rate is nothing but the distance, speed, like speed is what, distance upon time, how fast any reaction takes place. So in case of chemical reaction, like how fast the reaction takes place, how much time it will take to complete. Okay. Now we have another type of rate, like average and the instantaneous rate of reaction. Some reaction considered as an average rate of reaction, some reaction considered as an instantaneous rate of reaction. Okay. Average rate depends upon change in concentration of reactant or the product and the time taken for that change to occur. So basically average rate जो होते हैं, that will like initially, like from initially T1, okay, the rate is R1, the rate of reactant is the concentration of reactant is R1. At time T2, now the concentration of reactant decreases, become R2. So now if you have to find out the rate, you will take the average. Now you will take T2 minus T1, R2 minus R1. This is the average. Okay, this is what we called average rate of reaction. Instantaneous rate of reaction, like when you want to calculate the speed at some instant, right? किसी particular instant पे if you want to check, like suppose when you start your bike and when you started moving, suddenly some point, like there is some camera and all installed on a highway. Okay, so when you pass that camera, what happened? Instant, what is the speed of your car mentioned there? Okay, so that is the speed of car at the instant. At that particular moment you have 60 or 70 km per hour. But on an average, when you start from the beginning and when you end at the final destiny, so when you calculate from final to initial, right, then that is the average one. Instantaneous, at that particular moment, what is the speed? Clear? So this is the general reaction we have already discussed. Now here the average and instantaneous rate. See, instantaneous, when you started find down the rate at particular instant, right? Like suppose at this point you want to find out the rate. So what you will do, just draw the tangent and you will get the instantaneous rate. So this is basically the difference between instantaneous and average rate of reaction. Okay, mathematically instantaneous rate of reaction or average rate of reaction expressed like this. Always it is expressed by delta. See, this sign is what? Delta. Okay, this is the delta sign. So delta R by delta T, delta P by delta T. Here instantaneous rate of reaction always represented by D. So instead of using delta, here you are using a small d. So whenever you will see any rate of chemical reaction, okay, when it is given in the terms of delta, this triangle, that means you have taken the average value. If it is given a small d, that means at the instant time, right, the rate of chemical reaction given. Now let us see what are the factors which affecting the rate of chemical reaction. The factors which affect the rate of chemical reaction, basically nature of reactant. Okay, nature of reactant means how the nature of reactant affect the rate of reaction. See, if the reactant or if the compound is made up of ionic substance, react much faster than the covalent. So like we know that ionic and the covalent compound, ionic compound made up of ions, okay, and the covalent compounds are the non-polar one. So basically the ionic compound dissociate very fast in the presence of water. Okay, so very quick reaction you will get in case of ionic compound, right? Like suppose if you have ionic compound like salt, NaCl, when you mix NaCl in water, what you have seen? Very fast NaCl dissolve in a water. Okay, at the same time, when you dissolve sugar, which is C6H12O6, that is also polar but not ionic, it will take some time. Apart from that, if you want to dissolve stone in a water, it's not going to dissolve. Okay, so if the compound is made up of ionic bond, right, dissociate very fast, react very fast, right? So the rate of reaction increases if the reactant made up of ionic bond as compared to covalent. Concentration of reactant or the concentration, the rate of reaction is further directly proportional to concentration of reactant. Now, suppose initially you have lots of reactant molecule. Okay, so initially what happened? You have lots of reactant molecule. So all the reactant started converting into a product. So very fast you will get the product. Very fast product form. After some time what happened? Now the product increases, the molecule, reactant molecule slowly decreases. So now it will take little bit more time to convert into a product. So जैसे जैसे concentration, more the concentration of reactant, more the product you will form. Okay, as the concentration of reactant decreases, right, the formation of product also decreases. Okay. Temperature, obviously the rate of reaction directly proportional to temperature also. If you increase the temperature, the rate of reaction increases. Okay, so what happened here? Like when you increase the temperature, what happened? The molecule's kinetic energy increases. Due to the increase in kinetic energy, the molecule started moving, so the bond breaks between them and ultimately it joins with, or ultimately it bonded with other molecule to form a product. Okay, so that is what we call the effect of temperature. While increasing the temperature, the bonding between the molecule break down, so that they are free to bonded with another atom to form product. Okay. Then presence of catalyst. What is catalyst, guys? Catalyst basically are the molecule which enhance the rate of chemical reaction, which increases the rate of alter the rate of reaction, basically you can say. Like suppose any reaction A plus B has to convert it into AB. Initially it will take longer time, okay, but as soon as you mixed a catalyst within them, that catalyst increases the rate of reaction by decreasing the activation energy. What is activation energy? Activation energy basically represented by EA. Okay, so this activation energy is that amount of energy which is required to initiate any particular reaction. Like whenever you have to start your bike, right, you have to add like आपको चाबी लगानी पड़ेगी ना गाड़ी में. So when you put key into the bike and when you kick, then only the bike is started na. So that is the minimum amount of energy required to start your bike. So similarly, activation energy is also the minimum amount of energy required to initiate any reaction. Now few reaction required lots of activation energy. वो कहते हैं कि नहीं मुझे इतनी energy चाहिए तभी मैं start होगा. तो it will take time to reach to that particular energy. Okay, but once you add the catalyst, now what happened? The rate of now the activation energy decreases, and as soon as the activation energy increases, the reaction is started very instantly and you will get the product. So catalyst enhance the rate of reaction. Okay. Surface area of the reactant. Surface area of the reactant is what? Rate of reaction again directly proportional to the surface area. More the surface, more the reactant, more the product will form. Okay, like suppose you have a milk in a bowl, okay, and you have a milk in a glass. So the milk which is present in a bowl, okay, they have a more surface as compared to glass. So what happened? The milk molecule present in a bowl converted into a gaseous state, in a vapor state very fast as compared to glass. That's why the bowl milk becomes cooler as compared to glass milk. Okay, so similarly, as you increase the surface area, okay, the rate of reaction increases. If you want to add, like suppose you have a log of wood, आपके पास एक बड़ा सा wood का log है और you have a pieces of wood. Okay, so more the surface area, more fast the reaction takes place. Now the radiation, photochemical reaction. So radiation again increases the or you can say the radiation also affect the rate of reaction. Like few reaction takes place in the presence of light only, considered as photochemical reaction. So that also radiation or light also affect the rate of reaction. So these are some of the factors which affect the rate of chemical reaction. Okay. Now how you are going to write down the rate law, rate expression, and what is rate constant? See, rate law, first of all try to understand the rate law. Rate law always write down for the concentration of reactant only. Okay, rate law, the expression which relates the rate of reaction to the concentration of the reactant. तो rate law क्या बताता है? The rate expression related with what? Related with the rate of reactant only. Here we are not talking about the rate of product. Okay, the rate only and only related with concentration of the reactant. Okay, so it is also called as rate equation or rate expression. So rate equation, rate expression, rate law, all are same, all are related only with the concentration of reactant. Like suppose this is the general reaction AA, BB, CC, DD, where A, B, C, D are the stoichiometric coefficient. So now here the rate expression for that reaction is rate of reaction is directly proportional to A and B. So now suppose if this is the reaction, okay, so the rate is directly proportional to what? A and B. Okay, X and Y are the, again, coefficient. X and Y are the stoichiometric coefficient. Okay, so this is how you are going to write down the rate law or rate expression for any reaction. Okay, now R. Okay, now see, this is how you are going to write down rate. Now to remove this directly proportional, what you are going to add? R is equal to K A X B Y. Okay, this is how you are going to rate law, right? To remove the K, to remove the direction of proportionality, you are using K. K is what? Rate constant. Okay. So now suppose the reaction R is equal to what? K A B X Y. Now what is this R? R is your rate only, na? And how you are going to define the rate? Rate defines the concentration per unit time. Okay, so dr by dt is equal to what? K A B X and Y. Okay, so now what happened? This equation, this form of equation is known as differential rate equation, where K is the proportionality constant, which is called as a rate constant, velocity constant, or the specific reactant rate. Alright, so like this you can define this. Now rate law, rate expression and the rate constant. So here the rate law is the expression in which reaction rate given in the terms of molar concentration of reactant. So whatever you have learned till now given in the written form. So just try to read it after this. Now what is rate constant? That K is the rate constant. How you are going to define the K actually? So the rate of reaction where K is known as rate constant. Now when the concentration of the reactant A and the concentration of the reactant B is 1 mole per liter, just imagine if the concentration of the reactant A and B is 1 mole per liter, then what happened? The rate value R is equal to what? K A into B. So now what happened? If these values are 1 mole per liter, then ultimately R becomes K only, na? The rate law or the rate of a reaction equals to rate constant only. R becomes K, the rate of reaction equals to K. Thus, the rate constant of a chemical reaction defined as the reaction rate when the concentration of each reactant is unity. Okay. Now what is order of reaction, guys? Order of reaction basically, is the experimental value. Okay, it is not a theoretical value. The order of reaction is basically the sum of the power of the concentration of the reactant in the rate law expression called order. So like suppose you have written now R is equal to what? K A B. Okay, so this is what? X and Y. Okay, so now what is the order of reaction? How you are going to calculate the order of reaction? X plus Y. So this is the order of reaction. The sum of the power of the concentration of the reactant in the rate law expression. It's not like everywhere. In the rate law expression called order. Okay. So X is the order of reaction with respect to A. Y is with respect to B. So the total order of reaction becomes X plus Y. Now, it's not like you will get it just by seeing the reaction. ये जो order है ये आपको सीधे देख के नहीं पता चलेगा. Okay, it is the experimental value. You have to perform the experiment, then only you will get the power of concentration. So order of the reaction may be 0. Maybe you have a 0 order reaction. You have a first order reaction, second order reaction, third order reaction, or even you will get a fraction. Depending upon order of reaction, okay, the reactions are termed as zero first or second order reaction. Depending on what? Depending upon order of reaction. Okay, the reactions are termed as zero order reaction, first order reaction, and like if the power becomes zero, तो जीरो, अगर x प्लस वाई 1 है तो 1, 2 है तो ऑर्डर 2 हो जाएगा. A zero order reaction means that the rate of reaction is independent of the concentration. अब अगर like suppose you have okay, so if anything, right, having a power 0, the value becomes 0 only, na. So ultimately the rate of reaction is independent upon the concentration of reactant. So if the reaction is zero order reaction, nothing to do with the reactant, na, nothing to do with the concentration of the reactant, because it is independent, it becomes 0 only. Okay, the order of reaction cannot be predicted merely looking, that is theoretical, but determined experimentally. So this is what we call order of reaction. Now for zero order reaction, right, the unit is mole per liter per second. This is important for your exam. Sometime directly they will ask you the questions with related to unit. First order reaction per second, second order reaction mole per mole, liter per second. So just try to mug up the units actually. Okay. Now what is molecularity of a reaction, guys? Molecularity means what? Molecularity of a reaction is simply the number of reacting species. Okay, the number of reacting species, that how many atom, molecule or ions reacting to produce a product. So that number of molecule, ion or atom is considered as a molecularity of a reaction involving elementary reaction. So basically, like suppose this is ammonium nitrate. Okay, so the ammonium nitrate gives you N2 plus H2. So only one molecule, ammonium nitrate, only one molecule react here, na. So this reaction is unimolecular. Okay, now here see 2HI. So HI plus HI becomes 2HI. So two molecule of HI reacts together. So the molecularity is bimolecular. The reaction is bimolecular. 2NO plus O2. Now see, this is 1, this is 1. So 2NO, NO plus O2. So three molecule reacting together, the reaction becomes trimolecular. So this is what we call the molecularity. This is the basis how we are going to determine the molecularity of any particular reaction. Okay. Now what are the difference between molecularity and order of reaction? Sometime directly you may get a question, guys, here. Molecularity is the number of atom, ion or molecule which colloids with one another, right? Whereas the order of reaction is the sum of the power of the concentration. Okay. Similarly, molecularity of a reaction cannot be zero, right? Molecularity can never be zero. But yes, your order of reaction becomes a zero. We have a zero order of reaction, but because कोई मॉलिक्यूल ही नहीं होगा तो प्रोडक्ट कैसे बनेगा? रिएक्टेंट के साथ ही तो प्रोडक्ट बनते हैं ना, रिएक्टिंग स्पीशीज ही तो प्रोडक्ट में कन्वर्ट होते हैं. सो मॉलिक्युलैरिटी नेवर बी जीरो. It is a theoretical concept, but it is what? Determined experimentally. With the help of experiment only we can determine the order. it is always a whole number, like 0, 1, 2, 3, 4, like 1, 2, 3, 4, like here it may have a fraction value. Okay, you will get a fraction. The overall molecularity of a complex reaction has no significance. Individual step has its own molecular. So now we have two types of reaction, elementary reaction and complex reaction. Elementary is a single step reaction, complex is a multi step reaction. So elementary reaction में क्या होता है, what is in the elementary reaction? Only one step, reaction completed. So the molecularity always calculated for elementary. For complex reaction, we are not going to tell, because once the reaction is started, it will take 2 or 3 steps and then you will get a product. So here we cannot count the molecularity. We always count molecularity for each individual step, but order of reaction, we can take a overall order of reaction. Okay, so these are the very important differences between, your molecularity and order of reaction. Then another very important term is half-life time, right? Half-life is what? Half-life of a reaction is the time in which the concentration of a reactant is reduced to 1/2 of its initial concentration. So like suppose initially the concentration is 10. Now whatever the time taken to reduce the concentration to its half, right? So initially suppose the time is T1. Now the time is T2. So at T1 you have full concentration. At time T2 the concentration decreases to its half of its value. So this time is considered as a half-life time. Okay, half-life time is represented by T half. So T half always tells you that half time taken, like how much time taken to reduce the concentration half from its initial value. T half for zero order reaction, like this is the K, R0 minus R reactant initial, like final, then T half, like this you will get the R0 by 2K. So with this you can say that T half for zero order reaction is directly proportional to the initial concentration of the reactant and inversely proportional to the rate constant. So this is very important. Most of the time you will get question with this particular, segment. So here it says that T half is directly proportional to the initial concentration, inversely proportional to the rate constant. Then we have pseudo order reaction. Pseudo means what? Pseudo means, guys, false. Okay, pseudo means false. So false first order reaction, that means a reaction which pretend it is a first order reaction but it is not. The reaction which are not truly first order but under certain condition it become first order, that is called pseudo order. Initially all the reaction which is first order from the beginning only, but some reaction when you apply certain condition then only it become first order. So that is called pseudo order reaction. So the reaction which are not truly first order but on applying certain condition becomes the first order. For example, hydrolysis of ester. So here whenever the ester mix in a water, what you will get? Acid and the alcohol. So from this the rate of expression should be R is equal to K ester water. This is the rate expression or the rate law. Since the hydrolysis takes place, excess of water and the concentration changes of H2O is negligible. So therefore R is equal to K ester and K dash become K H2O. So now it become, like initially it is not first order but on applying more and more water, now what happened? The ester started breaking down and you will get the first order reaction. So this is what we call pseudo order reaction. So that's all about your chemical kinetics. I hope you have understood the concept, guys. Okay, whatever the topic we have covered here, just try to revise it from your book. Definitely you are going to understand now each term. Let us solve few questions. The rate of reaction depends upon. On what factor the rate of reaction depends? Yes, try to solve. Temperature, catalyst, concentration of reactant, all of the above. So definitely it depends on all. Temperature, catalyst, concentration, everywhere. Next, for the reaction 2A plus B gives C. The rate law is given R Ka2B. The order of the reaction is very easy. Here see the rate expression given Ka to B. How you are going to calculate the order of reaction? Just add the power of the concentration of the reactant. So 2 plus 1, nothing is 1. So it's a 3. So it is third order of reaction. Then alright, so that's all about your chemical kinetics. Just try to revise. I hope you have understood all the terms. Try to practice questions. There are some more, graphs and all we will discuss later. But till now, this is the basic. Try to go through all these things. With this, thank you everyone. Bye-bye. Take care.